All right, so in this video, we're briefly going to discuss standard form versus vertex form and what that's going to mean and or look like in different situations. So real fast, let's just talk about what the differences are. So let's get into some definitions. So standard form looks how you're accustomed to seeing it. So ax squared plus bx plus c is f of x, right? That's what makes us a function is we've got y equals some function of x, right? Well, standard form, on the other hand, is going to require us to complete the square. So it's going to look familiar in that respect. So let's say we had f of x equals, so then we still have an a term, right? But it's going to be minus h and all squared here, right? And then plus k. And we'll talk about what these numbers mean and what they do as we go here in a second. There's some similarities here. So let's start with a concrete example. So let's say I had f of x is equal to 2x squared minus, let's say 8x plus 7, right? So that's in standard form. Okay, so we know what that's going to look like more or less. This a term is positive. We've already more or less figured out by now that that a term being positive means we're going to open upwards. We've also more or less figured out that this plus 7, the c here, is going to be our y-intercept. So whatever happens, we know our y-intercept is here at 7. Okay, now let's look at what this looks like over here in vertex form. So to do vertex form, we're going to have to complete the square with this same function here. So what I'd want to do is, well, we can't have an a term per se, right? So I'm going to factor out this 2 from out of the 2x squared minus 8x. So 2, and then I'm left with x squared minus 4x. And then that plus 7 is still sitting out to the side over here. Okay, then of course we're going to complete the square with what's left here inside. So we now have f of x is equal to 2 times, it would be x minus 2 all squared minus 4. Okay, and then we still have the plus 7 there. Okay, then I would redistribute the 2 back in, just like so, right? So that's going to put me at 2 times x minus 2 all squared minus 8. And then we still have the plus 7 sitting out there. And our final answer, and of course I'm showing a whole bunch of steps that when you get good enough at this, you may not have to do. But our final answer would be this here. Okay, and this is interesting because this tells us some things. So standard form can only tell us so much. Vertex form tells us a whole lot more, right? So this number h here, and I'll start using a different color. This number h here tells us if we're shifting to the right or left. So this minus 2 tells us we go to the right by 2. So we'll say 2 is there. And this k, or for us, this minus 1, tells us that we go down by 1. Okay, and what that means is our actual vertex, this is why it's called vertex form, the vertex of our parabola is given by h comma k. H comma k. And we see we're going to have that exactly, negative 2, negative 1. My bad, not negative 2, positive 2, negative 1. So that's going to put me here. And then, like I said, we have the same a term. It didn't change. That tells us that we're opening up. And then we know the y-intercept. So we can more or less guesstimate where we're going. Something like this. Kind of missed my dot for the 7 there. I'll just move it. That's going to bother me. We'll say it's right there. That's 7. But anyway, you get the idea. Okay, and we'll learn a lot more about how that all works in later subsequent videos and lessons. Okay, so there's your differences. Real fast, before I close this video out, I just want to point something out. So let's say A was negative, right? If A was negative, well, that of course means we would be opening downwards. Okay. Other than that, I think I covered everything else. Okay, so that does it for this video. Let me know if you have any questions. Otherwise, goodbye.